be calculating the area of an ellipse. So we all know the equation is pi times a times b, but where did that come from? Okay, so the graph of an ellipse is basically, looks like this. This is a, b, and negative b. So this is the general form x squared over a squared plus y squared over b squared equals 1. So now if we solve for the area of 1/4 of this, we can just multiply that by 4. And this is relatively simple. We just have to use a couple integrals. So if we solve for y, we get y equals plus or minus square root of b squared times 1 minus x squared over a squared. So now we just want to take the positive root because this is the positive root of one of these. So it's y equals square root of b squared times 1 minus x squared over a squared. So we can take the integral from 0 to a of this equation. Okay, so this is a relatively difficult integral to solve, so we can use trig substitution. Let me rewrite. Okay, so this was what it was. So if we set x equal to, dx, x equals a sine of t, then dx equals a cosine t dt. So now this becomes, if you plug in 0 for t, you get 0 to pi over 2, the square root of b squared times 1 minus sine squared of t times a cosine t dt. So this can reduce to b cosine t times a cosine of t dt, and you can move a and b out because they're constant, so ab integral 0 pi halves cosine squared t dt. Okay. So we know we can use a relatively simple formula, which is cosine squared t equals cosine of 2t plus 1 divided by 2. And now we just plug this into there, so it's ab 0 to pi halves of cosine 2t plus 1 over 2 dt. So this becomes 1/2 ba times 1/2 sine of 2t plus 1, and the limits of integration are 0 to pi halves. So this equals 1/4 pi ab. So now if you multiply this by 4, you get pi ab. So that's where the area of an ellipse comes from.